What is a discrete uniform distribution? If x is a discrete random variable, x has equal probability to take on certain values, right? These x1, x2 are the values x can take. Then we say x follows a discrete uniform distribution. The definition of this uniform distribution looks very straightforward, but there are still several common misunderstandings. Let's start with writing out the probability mass function of x. Now, if x has equal probability to take on n different values, then the probability for x to be any one of these n values is 1 over n, right? The probability is only dependent on how many values x can take. So we write probability mass function f of x as, which is defined as the probability that x to be those values is 1 over n. N is the number of different values x can take. Now, please have a good habit of always mentioning the domain of the function whenever you need to write a function. Otherwise, so for example, if you miss out the domain, then the domain for x can be any real values, right? That would be the traditional way of thinking. Let's use the definition of discrete uniform distribution to have a look at these four distributions, whether we've got a discrete uniform distributions here. The first one, the dots are above the integers 1, 2, 3, 4, 5, 6. The most common misunderstanding on the uniform distribution is whenever x are evenly spaced out, so for example, x takes the 6 integers with spacing 1, then x is uniform. No, we look at the distribution of their probabilities, right? Not the x values. So you need to look at the dots, whether they are on the same height. So meaning if the probability mass function remains to be a constant, it's not. So x here can have 0.1 probability to be 1, 2, 5, or 6, but 0.3 probability to be either 3 or 4. Again, another reminder, the values of your probability mass function have to add to be 1. Right? Add all these probabilities up, you have to get 1. The conclusion here is if this x here does not have the same probability to be these 6 values, then x is not uniformly distributed on the 6 values. So it's not a discrete uniform distribution. Next one. Let's say x here can be 2, 3, 4, or 5 with these probabilities. Again, the probabilities here are not the same, so we say x here is not a discrete uniform variable. Next one. Why it is good here? X is not taking on the integers. However, the 5 dots, so at these 5 places where x can take, the chances are the same. Because there are 5 possible values for x to be, so the probability is 1 over 5, so 0.2. So this matches the definition of uniform distribution perfectly. We've got a discrete random variable, right? Discrete because we have a list of 5 values. Now you don't have to worry about what are the 5 values. It's just we have 5 dots. So x can take these 5 values with equal probability. So we've got a discrete uniform distribution here. Very similarly, the last distribution can take this 1, 3, 5, 6, right? They are not evenly spaced out, but the probability to take on one of these 4 values is the same, right? 1 over 4, because 4 values, 1 over 4, 0.25, probability to be these. So please fully understand the definition of discrete uniform distribution.